Today we're learning about determining the domain and range of a function. Very important lecture today, so make sure you watch it as many times as you need to understand these concepts. So let's recall the domain are all possibilities for the independent variable of a function, which is usually x. So think about, what can I put in the function? The range are all possibilities for the dependent variable, which is typically y. So think, what can come out of the function? It might also help you to think about visually. This is the x-axis. So when you're thinking about domain, you want to think left or right, how far can the function go? And for range, how high or low can the function go? What are the possibilities for y? If you're a visual person, this might help you. So a linear function, for example, let's think about a line, what it looks like. It can slope up or down, but we always have arrows on either end. And this is a possible equation. So all linear functions, you can put any real number into them, okay? You can go left or right as far as you want to. So that's any real number. But what's unique with linear functions is that the y value can also be any real number. Anything can come out of this equation if you just put the right x value in. And up and down, the linear function can go as high or as low as you want it to. So y can be any real number. Now, the only time this is not true is if you're in a realistic situation. So say you and me, I was ordering t-shirts, okay? So that would be a linear function, but the domain would be the number of t-shirts ordered. So it would have to be an integer above 0, 0, 1, 2, 3, something like that. And the range would be how much was spent on the t-shirts. So it would again have to be above 0, but it could be any real number above 0 because you could have a decimal or something like that for price. So you have to look at the situation to determine what your domain and range is if it's a realistic situation. Otherwise, for linear functions, they always have any real number for domain and range. Quadratic functions, however, look a bit different. So if you think about a parabola, it could look like this, or it could face down like that. Okay? So all quadratic functions can go left or right as far as you want, and anything can go into their equations. So x is in the set of all real numbers. Okay? But the range, you can't go as high or as low as you want. Because of the vertex, it'll either have a lowest point or a highest point. You can't go anywhere you want. So the range is determined by two different things. Well, first of all, the vertex, but the y value of the vertex. Okay? And then it's either all above that y value or below that y value. And that's determined by the a value. So if the a value is positive, it opens up and it's all above the y value. If the a value is negative, the parabola opens down and it's all below that y value. Okay? Again, unless it's a realistic situation. Then you would have to restrict domain and range depending on, height versus time. Time has to be positive, things like that. You'd have to think that through. So for example, if you have y equals x squared minus 3. So think about what that looks like. That's just the parabola transformed down 3 units. So it looks like that. So your vertex is 0, negative 3. So the domain here can be any real number. But what about the range? Well, we have to look at the y value of the vertex, which is negative 3. And we have to look at the point that the parabola opens up. So the a value is positive. So that means that your y is always greater than or equal to negative 3 and y is in the set of all real numbers. So your domain is always anything, but your range is going to be y such that y is either greater than or equal to, or less than or equal to the y value of the vertex, comma, y is in the set of all real numbers. Okay? So it's going to be greater than or equal to if a is greater than 1, so it opens up, and less than or equal to if a is less than, sorry, this should be 0, both cases. If a is negative, so the parabola opens down. Okay, a square root function. A square root function looks something like this. Boop. Or it can look something like this. Boop. Okay, it can go either way. It can go upside down. But the point is that it's one arm that continues infinitely in only one direction. So that means that the domain of a square root is restricted. It can't be anything. So it's determined by what is underneath the square root. Okay? So what can go under the square root so that it is still greater than or equal to 0. So let's look at an example before we get to range. So let's say we have y equals the square root of 2x. Okay, well, the domain is anything above 0, because whatever is under the square root has to be positive or greater than 0. Okay, or including 0. So it has to be, I should say, non-negative. So positive or 0. So in order for the square root to be non-negative, x has to be greater than or equal to 0. What if you have this function, the square root of, let's say, 2x plus 4, and then outside of the square root minus 1. So 2x plus 4, whatever is under the square root, has to be greater than or equal to 0. So now we just want to isolate x to see what it has to be so that this whole thing is non-negative. So you just have 2x is greater than or equal to negative 4. You just move it over. So x has to be greater than or equal to negative 2. So if x is greater than or equal to negative 2, you know that whatever is under the square root is positive, and therefore that's the domain. Sorry, it's non-negative, positive or including 0. But what about the range? The range is restricted because whatever comes out of the square root has to be 0 at the very lowest, and then it can go up higher than that. So because the output from the square root is 0 or greater. So in this case, think about what y can be. Well, the output of this, the very lowest it can be is 0. So then that means that the whole function has to be greater than or equal to 0. But in this case, we have this square root stuff and then minus 1. So the very smallest thing that can come out of here is 0. And then anything else above 0, like 1, 15, 3,000, those could all come out of here if you put in the right x. But the very smallest that can come out is 0. So the very smallest thing that can come out of the whole function is negative 1, because you would have 0 minus 1. That's the smallest. So that means that the range here would be y is greater than or equal to minus 1. So then you could write it in proper domain and range notation. So let's try one more example. What if we had y is equal to negative square root x minus 2 and then plus 5? So I want you to think about what the domain and range would be. Why don't you pause this and see if you can think about this on your own before I explain it. So the domain has to be anything that would make the square root 0 or greater. So x minus 2 has to be greater than or equal to 0. So that means x has to be greater than or equal to 2. That's your domain. Now what about your range? Well, what comes out of here has to be greater than or equal to 0. So that means what comes out of here has to now be less than or equal to 0 because you're making it negative. So if 0 comes out of there, it's still 0. But if 1 comes out of the square root, then it becomes negative 1. If 25 came out of the square root, it would be negative 25. So 0 plus 5, okay? So that means out of this whole function, these are all negative numbers, and then you add 5. So y has to be less than or equal to 5. Okay? The number 5, because greater than or equal to 0 from here, and then you add 5. But it's the less than because these are all becoming negative numbers. So 5 is actually the very highest number that could come out, and then everything else has to be less than 5. If you're having trouble understanding this, pause the video now and try just putting in different values for x and use your calculator to see what comes out. Make sure that you're putting the negative. So do that. Let's say you put in 3. So you do 3 minus 2, which is 1. The square root of 1 is 1. Negative 1 plus 5 is 4. So make sure you're doing it properly in that order. Reciprocal functions look something like this, okay? They're the ones that kind of look funny, something like that. So they have an asymptote, okay? So it's something like y equals 1 over x minus 3, and then maybe a plus 5 or something on the outside. So the domain is restricted by what x value makes the denominator denominator 0. So if you look at an example, let's just say y equals 1 over x plus 3. X cannot be equal to 0 because you know that we can't divide by 0. Okay, so that's the restriction there. It can be anything else, it just can't be 0. And that would correspond to the vertical asymptote. And let's say you had y equals 1 over 2x minus 4 plus, 7. Well, this denominator just can't be 0. So 2x minus 4 cannot be 0. So 2x cannot be 4. So x cannot be 2. That would be the domain of that function. But what about the range? The range is again restricted by the fact that the denominator can't be 0. So then you look at the whole function. Okay, so it's also restricted by the fact that the denominator can't equal 0. Okay, so if you look at this function, think about this. You can never have 0 come out of this part, okay? Because you can't divide by 0, and if you divide by 1, you just get 1. So nothing in the entire world, no possible x, will get a 0 out of this. So because you can never get 0 out of this section, That means if you look at the whole function, you can never get 3, because you will never have 0 plus 3. So that means that the range is just y cannot equal 3. In this case, again, if you look at the fraction part, you'll never get a 0 out of there. So that means out of the whole thing, you'll never get a 7. So the range in this case is y cannot equal 7. So when you're looking at reciprocal functions, you're always going to have x cannot equal whatever makes the denominator 0. And y cannot equal k if you have it of the form y equals 1 over some blah plus k, where k is this number up here. Okay, finally we look at absolute value functions. So absolute value functions, they kind of look like a parabola. So the domain is not restricted at all. So what it actually is always x is in the set of all real numbers. But the range is restricted by the y value of the vertex. Okay, because the absolute value signs mean that it always has to be positive. So let's say we have y equals the absolute value of x minus 4. Okay, so here x can be anything, but y would have to be greater than or equal to 0. Because whatever comes out of these two lines, the absolute value lines, has to be positive. So the lowest, or non-negative, that I should say. So positive or 0, which means non-negative. So the lowest thing that could ever come out is 0. Everything else has to be above that. But what if you had y equals the absolute value of x minus 4, but then on the outside you had a minus 3? So whatever comes out of here has to be non-negative, so 0 or higher. So that means whatever comes out of the whole thing, so whatever, if this is greater than or equal to 0, so the whole thing is greater than or equal to minus 3. Okay, now what if we had another one? Y equals negative absolute value x minus 4 minus 3. How does this negative change things? Well, it changes things because instead of being greater than or equal to negative 3, now everything's less than or equal to negative 3. Because what comes out of here is non-negative, but then it becomes negative, and then gets lowered down 3 more. So if 0 comes out of here, then your y value is now negative 3. If 1 comes out of here, it's now negative 1, and then down another 3, 4 to 4. So the highest it can ever be is minus 3. So now this is your range. So word problems will place restrictions on domain and range based on what's realistic. So for example, if you're looking at this, where you have a pebble falling off the CN Tower, what does that look like? So we have this equation, which once we put in that g is the acceleration due to gravity, it's actually the square root of 2 times 9.8 meters per second. So it would be 2, and then the 9.8, and then whatever your distance is, d. So this can be simplified to 19.6d. So what this looks like is something like this. Okay? It's not a picture of the pebble falling off the CN Tower. It's the velocity. So as the distance gets higher, the velocity gets bigger. But you have to think about, should this arrow really be there? The arrow means that it goes on forever. Is that possible? Well, look at it. The CN Tower is 346 meters above the ground. So what does that have to do with velocity and distance? Well, that means that the greatest possible distance is going to be 396. So we have to stop this when distance is equal to 396. Okay? So that means that our domain is going to be distance such that, well, the lowest it can be is 0, greater than or equal to, and then the highest it can be is 396. Okay, now you have to think about what kind of number is distance. Well, it's any real number because it can also include decimals. But now our range will be how big velocity can be. So velocity has to be greater than or equal to 0. But how high can it get? Well, we have to look at what the velocity is at the distance of 396 meters, because that will tell us when it's hitting the ground. So go ahead and do that, figure out what that is, and you can check your answer with me tomorrow. Okay, so now I'm going to give you an example of each type of function, and we can figure out the domain and range. So in this case, the first thing we want to do is identify what kind of function it is. So right away, you should say, this is linear. So you should be thinking it goes on forever in either direction. So right away, you don't really have to do much work. You just know that x can be any real number, and y can be any real number. Phew, that was easy. So now we look at this example and we realize that it's quadratic. So that means that our domain is anything, but our range is restricted. Okay, it's restricted by the y value of the vertex and whether it opens up or down. So the a value is negative, so that means that this parabola opens down. So that means all y values will be less than or equal to the y value of the vertex. This is also in vertex form, so we can see that the y value of the vertex is 6. So in fact, the range is that y must be less than or equal to 6. Now we look at this example, and this is a square root function. So this might be the hardest for you to start understanding. So the first thing you got to think about is that my domain is restricted by what's underneath the square root. So that x plus 2 has to be greater than or equal to 0. So on the side here, you might want to do some work. X plus 2 has to be greater than or equal to 0. Well, that just means x has to be greater than or equal to minus 2. I just simply move the 2 to the other side of the inequality, just like I would an equal sign. So that is my domain. Now my range is determined by what can come out of the whole function. So what comes out of here has to be greater than or equal to 0. And then I'm not adding anything above or subtracting anything below that. So my range is just that y is greater than or equal to 0. Now finally we have a reciprocal function, which again just means that you're going to have something that x cannot be equal to and something that y cannot be equal to. So you just have to think about what is that one number. What is that one number? Okay, so the denominator just can't be 0. That's what you got to think about. So my x can't be 1, or else that would make the denominator 0. So that's the number I put there. And for range, I think, okay, well this can't all be 0. So the whole thing can't all be 3, because I'll never have 0 plus 3. So y cannot equal 3. Finally, here's a typical example you would have gotten from grade 10 quadratics. So they have 24 meters of fencing to enclose a rectangular garden at the back of their house. Okay, so that means that the perimeter, so if we have it like this, here's one length and two widths. So 2w plus L has to be equal to 24. Okay? So we want the area as a function of the width. So we want area to be something, not just length times width, but we want the length to also be only having a w in it. So we have to take this and rearrange it. So L is equal to 24 minus 2w. So I can just take that and sub it in for the L. So now my area as a function of width is 24 minus 2w times w. Okay? And this can be rewritten as minus 2w squared plus 24w. So let's determine the domain and range of this function. Well, the domain first has to be whatever the width can be. So we know already that width has to be positive, but it's going to have a top end depending on what it can be. So let's look. What can width be? You've got to think about that. Now range is area, so what is our greatest area? Has to be positive. Well, what's the greatest the area can be given that the perimeter is as such? So the area, we can look at this by doing the vertex, finding the y value of the vertex. And this, I want you to think about what could W be, knowing that this has to be 24. Okay? What does this domain have to be? And we'll finish that example up tomorrow. Please read over the success criteria and make sure that you're confident. I know this is a difficult lesson and a difficult lecture, but once we learn transformations and you can visualize what these different changes do to your parent functions, I'm hoping that this will maybe seem a little bit simpler for you.